Okay, so let's just a quick look at this guy. I don't think we need to do too many problems. I think we'll just do a few and then you guys can work. So what about something like this? What's our thinking here? We we want to find any horizontal asymptotes. So there's two parts. Part A, we want to take the limit as x approaches infinity and the limit as x approaches negative infinity. So you guys fill in the blanks for me. If you can talk me through this one and maybe one other one, then I'm going to turn you loose. Okay? So you're on the spot. Limit of f of x as x approaches positive infinity would equal the limit of what? Okay, but now, so true, but if we're approaching positive infinity, we're being specific about this. It makes the problem a little bit easier. If we're approaching positive infinity, we're looking at the square root of the leading term on the top, right? That's going to be the dominant term. If x is approaching positive infinity, what is the square root of x squared? See what I'm saying? I mean, you're right, Ethan. It's the absolute value. The square root of x squared over x equals the absolute value of x. But if x is positive, what is that? See what I'm getting at, everybody? It's like if we already know x is positive, then it's just x, isn't it? Right? Okay, so then we're taking the limit of the square root of 9x squared. Well, what's the square root of 9x squared then? Square root of 9 is 3, right? So I'm getting a 3x over x. So I get 3, right? Everybody with me? Okay. How about the limit of f of x as x approaches negative infinity? Now, what's that term going to give us if we're approaching negative infinity? Okay, so it is the absolute value of x. But if x is negative, what's the absolute value of x equal to? Well, then okay, it's going to be the opposite of the input things. It's got to make it positive. Everybody see that? Right? So the way we write that is a piecewise function, remember from yesterday, or a couple days ago. The absolute value of x, when x is positive, when x is positive, it's just x. It doesn't have to do anything, right? If x is negative, then we have to make it positive by multiplying by -1. Okay? So up here, we're going to get on top, we're going to get a negative 3x. On the bottom, we have our x. So we just get -3. Okay? We good with that? I figured out something kind of cool. I've used this thing for years and years and years. And I don't know if this is new or if I just cluelessly missed it forever. But there's a way. I'm anxious to know if this works. In a couple problems, I was able to do something called an instructor tip. And so I typed in. I think what's going to happen is when you get to the problem, it'll give you a little hint from me. So tell me when this is all done. Tell me if it worked. If it was okay. Because if it did, I think it's kind of cool. So then we get these two horizontal asymptotes, right? So this is going to give us the horizontal asymptotes y equals 3 and y equals -3, right? Y equals 3 would be our positive horizontal asymptote. As x approaches positive infinity, here's the horizontal asymptote at negative infinity. Okay, what about the other part? Find the vertical asymptote, okay? So how am I going to do that? Let's talk about that. So I've got this function. You guys tell me I'm doing too much talking. How would I know? Be brave. This is a good opportunity to kind of practice being brave. Have some confidence here. You guys are all really good at this stuff.
You could set the denominator equal to 0, then solve for x. Then that would give 1.
Okay, so what's the only possible place where we could have a vertical asymptote is 1, because that's a 0 of the denominator, right? What happens at 1 on the top? If I evaluate this directly, I'm getting 9 plus 2, so I get square root of 25 minus 5, so I get 0 on the top also. Okay, so if we have this indeterminate form, 0 over 0, how am I going to figure out what the outcome is? We're going to try to work smarter, not harder on this one. See if we can really finesse our way through this without having to do a whole bunch of work. If we can do a bunch of work, maybe you don't need to. Thoughts on that? So what's the deal with 0 over 0? Right, what did we say about that? And this is kind of a, I think most of the time probably in a high school calculus class, people would just say 0 over 0 is a whole. But it's not always, right? We're going to go a step beyond that. It's not always, it's indeterminate if under what condition, if I start off, if the limit is equal to, the limit of some function is equal to 0 over 0, under what condition are we going to get back a whole? Like, how do I know if I start off with a limit that's indeterminate? How do I know that that is indeed going to be a whole? What are we going to do? What are we going to do? Over here. Somebody over here. Go ahead. I remove the indeterminacy, and I get an answer, right? I get a limit, right? So after removing the indeterminacy, if I find out that the limit of f of x equals L, just some, L just means some number. We get a limit, then I get a whole, right? Okay, under what condition would we get a vertical asymptote? Okay, when I remove the indeterminacy, that's my goal, right? If I end up with a number over 0, then I get a vertical asymptote, right? Okay, so then up here we just have to answer that question. When I remove the indeterminacy of this function, right? So it's no longer 0 over 0, which one of those two things would happen? Now we could do the process. What would the technique be to take that limit, to evaluate that limit? Let me get rid of this. It's kind of getting hard to see. So here's the function. We're trying to take that limit. What would the technique be? Remember, this goes back a little bit, a couple weeks. Okay, it's the rationalizing technique. We multiply top and bottom by the conjugate of the top, right? And that would work. Definitely would work. I mean, guaranteed it's going to work. But when it does, what's going to be the outcome? What has to cancel? Has to be x minus 1s, right? Everybody get that? Because x minus 1 is the sort of the offending factor. That's the one that's causing the 0 over 0 nature, right? So we know when we do this limit, we're going to get something like limit of f of x as x approaches 1 is going to be x minus 1 on the top times some stuff, right? And on the bottom, we're going to get, and it might just be an x minus 1 on the top, honestly. We don't even know if there's going to be any stuff. That's kind of a question mark on that one. On the bottom, we're going to get x minus 1, definitely times some stuff, right? But when I cancel those out, is there any chance that we're going to get another x minus 1 factor on the bottom? No, right? That's not going to happen. Okay, so we already kind of know what's going to happen here, don't we? We know that when I do the rationalizing technique, the x minus 1 is going to cancel off of the bottom. And so this can never happen, right? Everybody see that? That's a pretty, I mean, that's a pretty sophisticated way to sidestep this, but it works. And you could just do the math too, right? Give me 1 to 5 on that. Is that making sense? I mean, that's kind of a, yeah, that's what we kind of like to do in math, honestly. Like that's, as you get better and better at it, you can find ways to avoid having to do so much work. You get lazy a little bit, but you could just do the rationalizing technique also. So what are we going to find here then? Is there going to be a vertical asymptote? No. There's not going to be, right? Maybe just as a quick review, you know what? Let's just go through that process. It doesn't take that long. Okay, so if we're going to take this limit, you already told me what to do. We're just going to multiply top and bottom by the conjugate of the top. Okay, so then what's that giving us? On the top, what are we going to get? A squared minus b squared. A squared minus b squared, right? On the bottom, we're getting all this stuff. Times that whole big thing, right? I'm just going to do this for a second. I'm just going to times that big orange factor, right? So if we combine like terms, I'm getting 9x squared plus 2x minus 11. Okay. Plus times that big orange term on the bottom. Okay. That's kind of a nasty one to factor, right? Can I cheat? I mean, those are the worst kind of factor, aren't they? Right? Where we've got a is not equal to 1. And there's a process, right? You guys, we need to review that. I mean, do you guys know how to factor? Remember how to factor those? Okay. There is a couple ways to cheat, though, right? We know by the factor theorem that if I know a 0, I can always turn a 0 into a factor, right? That makes sense. So like, for example, if I know that if x equals c is a 0 of f of x, then what is a factor of f of x? What would the factor be that goes with that 0? Like if I know that 2 is a factor of some, or is a 0 of some function, what's guaranteed to be a factor of the function? It's minus 2, right? Okay, how do you get there? Well, one way to get there is just to think about what a 0 means. Okay, yeah, if this is a 0, then what would equal 0? X minus c. Isn't that just a solution of x minus c equals 0? Right? And so x minus c is the factor whose 0 is c, right? Okay, so let's use that reminder to factor the top easily. What's one factor of the top guaranteed? What's the whole point of doing this? Why were we doing this rationalizing technique in the first place? To cancel the x minus 1s, right? So doesn't 1 have to be a factor of the top? And we can check it. It's easy to do. Like if I just plug in 1, I get 11 minus 11 is 0. So 1 is a 0 of the top, right? So guaranteed, the top is going to factor into x minus 1 times something. Agree? Well, I can find that pretty easily by just dividing the top by x minus 1 to see what's left over. Because what's it mean to be a factor of something, right? 3 is a factor of 12 because 3 times 4 is 12, right? So x minus 1 is a factor of 9x squared plus 2x minus 11 because x minus 1 times something, the other factor, is that, right? So we could just come up here and do a little quick synthetic division where our 0 is 1, the coefficients are 9, 2, and negative 11, and there's our remainder box. Bring down the 9, add, I get 11, there it is, right? So what's the other factor? 9x plus 11, right? So and then on the bottom we've got x minus 1, and then we've got that big orange factor up there. I just didn't want to write it a bunch of times, but it's 9x squared plus 2x plus 4. Okay. And, whoops, I wanted that down here, didn't I? And when I take my limit then, well, those guys cancel, and now I can just evaluate it, right? So I'm going to get, what's the outcome then? On the top, I get 20. On the bottom, I get 10, right? So I just get 2 to my limit. Okay, but my point from the beginning was, did we really need to do all that stuff? No, we didn't. Because we knew we were going to get something here and something here, some factors that weren't going to cancel. Okay, the x minus 1 was, there was only a linear factor on the bottom, and so when I cancel it, the x minus 1 is going to be off the bottom. Now, if the bottom had been something like this, if it had been x minus 1 squared, then we wouldn't have known. Then we would have had to have done some work. Because when we cancel one of those x minus 1s, there's still another one on the bottom, and we don't know if that one's going to cancel or not, right? Okay, does that help a little bit? Give me 1 to 5 on that concept again. Did that help a little bit? Okay. Okay. All right. You guys tell me, do we need to do this one or not? you're gonna see questions like this. What are the equations of the vertical asymptotes, if any, or horizontal or slant asymptotes? So what am I gonna do here? How am I gonna find if there are vertical asymptotes? Okay, he'll give me a quick summary. What's my strategy to find vertical asymptotes? Okay. Shay, you got an idea?
What was the question?
How would I find vertical asymptotes here? What's your thinking on that?
You remove the indeterminacy first, right?
Say it again.
You remove the indeterminacy.
Right, okay, if there is indeterminacy, right? So my first step would be probably what? Okay, I got factor top and bottom, right? Factor top and bottom, and either I'm gonna get some indeterminacy or I'm not. I'm gonna get some zeros up the bottom, possibly. I may not. You know, you could have quadratic functions with no zeros too, right? So it's possible that there are none just because there are no zeros at the bottom. But there are, aren't there? The bottom does factor. So if we do that, g of x equals, what's the bottom factor into? Okay. Top factors into what's that going to be? That's the top factor? Well, I don't think it does. Okay, so it certainly doesn't factor into 2 is not a 0 at the top, is it? Right? Everybody agree? So what's the outcome here? Are there vertical asymptotes? You're right, Cahill, how come? Say it again. There you go, number over 0 is an asymptote, and so if we evaluate this at 2, I get a number over 0. So that's a vertical asymptote. So we found that, right? Horizontal asymptotes, what would it be? As x approaches positive or negative infinity, what's that limit? One, isn't it? Yeah, right. We just take the limit of the leading terms, ratio of the leading terms, and the limit of x squared over x squared is the limit of 1, isn't it? Right? Okay. Give me 1 to 5 on that one. Okay, good. How about that one? Any vertical asymptotes? Thumbs up or thumbs down? Give you a second to think about it. Vertical asymptotes. Okay. What do you think? You see, are there any exclusive zeros at the bottom? Zeros on the bottom and not the top? Does that make sense? Okay. Andrew, what's a 0 at the bottom but not the top? What value of x makes bottom 0 but not the top? What do you think? Lucy? 2. Okay, right. Everybody see that? 2 is a 0 at the bottom, but if I evaluate the top of 2, I just get some number, right? So we know that 2 is a vertical asymptote. Any horizontal asymptotes? Thumbs up, thumbs down. Horizontal asymptotes. Okay. Yes, Julia, how come? There are not. No horizontal asymptotes. How come?
Because the top is 1 degree.
Okay. Top is bigger degree than the bottom. When do you get horizontal asymptotes? When they're the same degree, right? In that case, we just look at the ratio of the leading coefficients. Or what's the other case where we get horizontal asymptotes? Okay, if the bottom's bigger, which I may not have one handy here. No, I don't. But if the bottom is a bigger degree than the top, then in the limit, the bottom gets infinitely big compared to the top, right? It just goes to 0. Okay, those are our rules for horizontal asymptotes. Don't even have to do any work. That goes back been a few days, so let me just pull this up real quick. I gotta go back about 1,000,000 pages, but that one, right? Right? If the degree of the numerator is less than the degree of the denominator, we always get y equals 0, right? The limit at infinity is, or at either infinity is 0. If the degree is equal on the top and the bottom, we take the ratio of the leading coefficients. If the degree of the numerator is greater, so the top is a more powerful polynomial, you never get horizontal asymptotes, right? Okay, back to this one. Where are we? That, is that the one? No, that one. Okay, what about slant asymptotes? Thumbs up, thumbs down. This is stuff we talked about at the end last time. What do you think? Okay, Shay, how come you're right? You're right. Top's bigger by how much? By 1. Good. Okay, so remember, when the numerator is a higher degree polynomial than the denominator by exactly 1, right? Then you know that when I divide this out, I'm going to get a linear polynomial plus some remainder term, right? And we looked at an example of that, a couple examples of that. There was one, right? When we divided this out, we got, using synthetic division, we got 3x plus 6 plus this remainder term, 12 over x minus 2. And when you see that, this is the one, right, when I end up with a constant on the top and a power of x on the bottom, this is just like, this is its own polynomial, isn't it? Oops. That's its own polynomial where the degree of the bottom is bigger than the degree of the top. So in the limit, I know this one's going to go to 0 in the infinite limit, right? Limits at infinity. And I'm just left with this linear part. The equation of that line is my slant asymptote, right? So that's what we always look for. We know there's going to be a slant asymptote when you get the top 1 degree bigger than the bottom, okay? In this case, what would be the easiest way to find the equation of that slant asymptote? What kind of division am I going to do to simplify that quotient? Synthetic, yeah, right? All I got to do is synthetic. And so we could rewrite, if I do synthetic division here, what are the coefficients on the top? 3, 0, 0. Good. The 0 that goes out front? 2. So I bring the 3 down, 6, 6, 12, 12, right? So I could rewrite, I think that's probably that's the same one we did last time, isn't it? Exactly the same one. Well, there it is. So we get our constant is 6, coefficient of x is 3. And what remains over the denominator? 12. So there's the slant asymptote, right? Okay. Same kind of thing, right? We won't mess with, but what about the slant asymptote? Yeah, everybody sees we're going to get a slant asymptote. If we get a vertical one, actually we're not going to, are we? Because, or no, we are, because negative 18 is a 0 of the bottom but not the top. So we do get a vertical asymptote at negative 18, and we do get a slant asymptote, which we can find synthetically. How about that one? Any vertical asymptotes? Think about that a little bit. Now think smarter, work smarter, not harder on this one. Vertical asymptotes depend on a 0 in the denominator, right? Are there any zeros at the denominator? How come, Lucy? You're right.
Like, if you need a -1 and to the six.
Okay. Yeah, because the bottom is nowhere 0, right? There are no real zeros at the bottom. Okay. Everybody see that? If I set that equal to 0 and solve, I'd be taking an even root of a negative. That's not a real result. Okay. Are we going to get a slant asymptote? Thumbs up, thumbs down. Good. How would I find the slant asymptote? Long division. You guys okay with long division, or do I need to do it? Give me thumbs on long division. Okay. Thank you. I didn't feel like going through a whole long division problem. Okay, I think we're good. I think we're good. I know I didn't leave you much time, but I will give you tell you what, give you guys Monday to work on this in class. I know Monday's a little shorter day, but you can work on this, and now there's 2 assignments. It's kind of a lot of work. That way, get through the ones you can, and then come with questions, and I'll help you out with your troubles on Monday.